What's up? I'm gonna.
For consecutive.
Okay, we're gonna talk about. So guys, let me catch up to you a little bit. So this one, add 9, 2x equals negative 18, divide by 2, x is negative 9. Oh, you're the dead one, huh? So x equals 9, negative 9. So what is this one? I want you to notice something, right? Doing this step helps you set up the equation, and then it freaking helps you answer the question, right? If you don't do this step, you're kind of lost in the middle of it, not knowing what goes where or what even the question is. The question is, what are each of these? And if you don't tell yourself what each of those are, how the hell are you going to get them at the end? So this step, even though it is sort of, I'm saying it's a suggestion, it's kind of like if you don't do this, you're kind of shooting yourself in the foot. But
I thought you said it's x equal negative 18, not 9.
Where did I say x equals negative 18?
Over here. On mine, because I have
No.
negative 9.
X minus 9 is negative 18, yes. Right? What do you get for x? What is x? What do you get for x? Negative 9. Yes? Yes?
Yes.
Okay. That's this one, right? That's what x is. The other number was x, correct? This number is x minus 9, but x is negative 9. So this number is negative 18. How do you check it? Well, they're supposed to add to be negative 27, and they do. So I think, this is why I keep saying this about, I know the problem is easy, I know you can get the answer a different way, but that kind of feeds into you not really buying into how useful this is. But we're trying to get used to this with easy problems. So you have to force yourself to do this. It's going to help you. Let's look at the next one. 347. This is one where it gets a little bit more interesting, right? But it's still, what are the two players? One number and another number. And another one. So which one is going to be just x? Can you guys start to see how to figure that out? That is one of the most important steps in a word problem is which one is going to be just x, because everything else gets built off of that.
Oh, that'd be another.
Why another? Because the one number is a bunch of shit that you do to the other one. So you have to know the other one first. Does that make sense? You should be able to see which one you need to know first. I need to know this one first. Now that I know this guy, I can do 2 more than 4 times it. What's 4 times it? And then 2 more? Yeah. I mean, do you guys see that? So, no?
I didn't get that part. I have the answer right, but I didn't get that part right. Write it now. I believe that's
Well, no, because you never told me what the 2 numbers are. You see what I mean? You told me x is negative 3, but what are the 2 numbers then? Oh, I see. You sort of.
yeah.
Well, wait a minute. No, okay. You're going to see in a minute. Watch. Guys, it would be unbelievably rare for none of these to be just a letter. Basically, always for us, one of them is going to be just x, and the other ones are built off of that, right? So one number is 2 more than 4 times another. I have to know what he is first. You could call this guy 17x. You totally could. It would work. But why the hell would you do that to yourself? I'm going to call one of them just x and then build right off of that guy so that I have less shit, right? So you almost always want one of these to be just x. Because you don't know either freaking one. So one of them I'm going to call x. And then the other one is related to that one. Maybe. Now, what are these two supposed to do with each other? Add up to be negative 13. So then I get 5x, subtract 2, divide by 5. Now again, don't just circle that and keep going. Go up here, x is negative 3. So what's the one number? 4 times negative 3 plus 2. Is everybody cool with that? Because I know x is negative 3. Therefore, I know the other dude because these are related. 4 times negative 3, negative 12 plus 2. How do I check myself? Well, these do make negative 13 like they're supposed to. You guys see that? That's so nice to get to the answer and go, and there's a real quick way. Oh, they do make negative 13. Kick ass. Yes?
So an easy way to find out like how to visualize it, if you were to literally write it out, it would be like one number, so you put x is, and you put equals, 2 more, so then you put the plus 2, and then 4 times is another.
But see,
So the way I'm seeing it was
you can't do, it kind of sounds like you're saying it would be this, which is not true. X can't be equal to 4 times itself plus 2.
Yeah.
Yeah.
Because it says is, that's what was throwing me off.
I got you. So one number is, right?
Yeah. X.
4 times 1, 2 more, yeah. That would be fine. But you can't use x multiple different times for multiple different things.
So like say if I was to do, you see how one is 4x plus 2 and another is just x?
Yes.
If I had those flipped, would that still work?
No. No. Because what's the one number supposed to be? Negative 10. And what's the other number supposed to be? Negative 3. Yours would have been turned around. So I know, now listen, what I'm trying to get you guys used to, if I got Bill and Fred flipped around, is one of them going to be pissed when I pay them? Remember that problem earlier?
Yeah.
Isn't one of them's going to be like, I ain't saying shit. But the other one's going to be like, wait a minute, I didn't make enough money. So in general, you can't just flip these around. Now I know this one's a little less, nobody's going to get pissed. Nobody's going to hurt you, right? But still, I'm trying to get you used to the English names have to go with what value they have. Okay, maybe. Now we get to this one. I think most everybody got to this next one, and you're like, what the shit? So first thing is, what is an integer? We're going to see this word a few times. Yeah. Everybody, what the hell is an integer? Well, a whole number is a whole number. So real quick.
Yeah.
What's all right, stay with me. I'm going to tell you a brief history of numbers, right? Remarkably brief. There's something called the natural numbers or the counting numbers. So I always think about caveman back in the day, and he's counting his rocks, right? So, at the bottom is the subtitle translation of what he's saying. So it's 1 rock, 2 rock. That's the natural numbers. 1, 2, 3. They come naturally to us. Do you guys know that, for example, the Babylonian civilization, for most of their existence, had no symbol for 0? The idea and symbol for 0 had to be created, which sounds weird, but then when you think about it, every damn thing we do had to be created. So there were civilizations that had no concept of or no symbol for 0. You guys see what I'm saying?
Yeah.
It's really freaky. Actually, they developed 0 right before the civilization fell. It's kind of like, hey, look what I found. Oh, we're dead. All right. Anyway, sorry. Nothing against any Babylonians in here. I guess not, because they're all dead. So the next thing from natural numbers is whole numbers. So they just add 0 to the natural numbers, right? You guys kind of still with me? I don't know if this sounds at all familiar to you. So whole numbers, what's beautiful about whole numbers is 0 looks like a whole, so we call them the whole numbers. Holy shit. Then you get the integers. So if my caveman lost his rock, he's 0. So you had to come up with the idea of 0, whole numbers. And then if he borrows somebody's rock, he had to come up with the idea of negatives, because now he owes somebody. Right? So like he's got -1 because he owes somebody. You guys kind of with me? That's integers. Integers are whole numbers and they're negatives. So it's like the whole number line tick marks without the stuff in the middle. The stuff in the middle would be rational numbers and irrational numbers, but we won't get there yet. Okay, so you got to know what integer means. So somebody give me any integer. 7. How do you get to the next one? What's the next integer? 8. That's amazing. How do you get there from 7? What do you do to 7 to make it become 8? Add 1. Not any number, but 1. right? No, 1. Okay. Stay with me now. Watch. Do you know either of the integers in this problem? Those are the things I don't know, right? And I got 2 of them, don't I?
Yes.
2 consecutive integers. So I say the first one and the next one. I don't know either of them. So what am I going to call the first one? That's amazing. Or N, or W, or F, or whatever the shit you want to call it. I. Let's call it X. And we just established. Doesn't matter. Somebody said 7. I added 1 to get 8. The next one. Doesn't matter what number you gave me. Give me 343. What do you do to get to the next one? Add 1. So here is a number. How do I get the next one? There. That represents any pair of consecutive integers. Everybody cool with the word consecutive? The next one, the next one, the next one. I like it. So any question that says you have 2 consecutive integers that do this shit, these are the 2. This represents all of them. Does this represent 6 and 7? Yeah, if X is 6, this is 6 and 7, right? What do I want specifically, the 2 that do what?
Add up to 130.
Add up to, so if I take one of them plus the other one, it wants me to make
130, negative 130.
negative 130.
Or 135. sorry.
135, all right. I'm trying to crowdsource it without looking. There it is, yes. And then you solve it, right? That should be the easy step now. Are you guys starting to feel, one of these is always going to be X. The other one gets built off of that. There's some relationship. When they say consecutive integers, the relationship is one is one more than the other. What if I had 3 consecutive integers? The third one would be, holy shit, X plus 2. Right? You're good. You're right.
Okay.
Did you guys? Is that cool? And now just solve that equation. And notice, I want you, now that you've seen this one, I really want you guys to try to do 351 by yourself. They add 1 word in there. Let me see if you guys get how to do this. Finish that one up and try 351. Plus a word too.
I did.
It would work with a plus. It just have to be 2 parts. It should work with a plus.
Write it down. You have to write it out. I have to get it.
And this is still.
Yeah.
So you kind of added it up wrong when you checked it. So it should work either way. Because here's the cool thing. Either way captures the fact that one is 2 away from the other. So if you set it up differently, your answers show up in a different order, but they are the same answers. The same numbers. Bless you. Bless you.
Maybe it means.
Is it 68?
Oh, I should have added.
I just made this thing that I want me to destroy.
Is that cool, guys? Is that one? Now try to do 351. So the difference is they say odd. So give yourself an odd number and then what's the next one? Maybe an odd number, any odd number. 30. Huh? 3. What's the next one? 4. Odd. Odd. Consecutive. Okay, so now we get from 3 to 5. You got the pattern. And now they say 3 of them. So one's going to be X, and you just figure out what the next one has to be, and how to get even the next one. You just keep adding. It's that pattern. Yeah, divided by 2. Yeah. Divide 2. If you want x, right? That's this one. And the other one is that see, the thing with this one is the first one, the next one, and then the one after. Give me an odd number. What's the next one? What'd you do to give them you added. So you get from one odd number to the next one, you always add. So the first one is x, it's not like any of them, right? The first odd number is x, what's the next odd number? What did you just say? You already figured it out. Any odd number, the next one was 11. Look at me. The odd number, the first one was 11. How do you get to the next one? Add 2. So this one, where do you start?
21.
How do I get to the next odd number? So I got 2. And then what's the third one then? X plus 2 equals 4. You gotta add 2 again. So once we know the pattern is that, how do you get to the next one? Yes. You got 3. So the third number, just go the same thing. And then you get the second number. I didn't get so 3, add 2 to get 5. The next one is 7, so what do I do? So I have to add 2 to the x equals 2 plus 6. And then the next one is consecutive. That's right, that's 3, that's 3. That's 5, 7, 7, there's second.
Yeah, because it's.
Well, that's what you can just consecutive. That one added the word on. Even if it was even, those are also still
This shows my work.
Well, you didn't answer the question. You have one number and the question says find 3. So one number, next number, third number. First number, second number, third number. We don't have numbers, so you're gonna need 3 expressions. No, you're thinking that's what you do. All right, guys, everybody. Okay.
We're trying to understand.
I'll leave. I was gonna explain it.
So I got the answer wrong. So I don't think the way this works is you pull up each
Good.
I'm saying that so if you also do it correctly, the answer you get, then you put that in.
You would know the first one was, and you have to figure out the next two. So
Like to try to find your negative answer, then
you just keep adding 2 and then add 2. Yeah. But you can check just by adding it. All right, let me try again. The group that chastised me earlier has moved on to different topics, so I'm going to come back in. You're throwing something at somebody, which could be
My
bad.
homework.
You weren't talking about the content. You were talking about throwing it at
No, I
somebody.
was saying I shouldn't.
It doesn't even matter. So, 3 consecutive odd integers. So they threw the word odd in there. How are odd numbers related? Every odd number is how far apart from the next one? 2. So I've got 3. So I can say first number, second number, third number. Call them something, right? You with me? First one, I don't know what the shit it is. I'm going to call it X. The second number has to be the next odd number. So it's got to be that one plus 2. And then how do I get to the next one? I add another 2. So let's check this. How do I check my work so far? If that's an odd number, give me an odd number. 7. The next one is 7 plus 2 is 9. That's true. And is the next one 7 plus 4, 11? Yeah, 7, 9, 11. So we just represented those 3 specific ones, but whatever X is, it will give me the next 2. Okay, I like it. So I specifically want the 3 consecutive odd numbers that add up to be 51, right?
Yeah.
So then I have to add this number to this number to this number, and that makes 51. Maybe?
Yes.
No? Yes, okay. Not a lot, okay. But it is new. You're probably not used to. And this is the whole thing about word problems. You represent a relationship, right? And this is a relationship you never really stop to think about. But how are consecutive odd numbers related? They're always separated by 2. So this is exactly how you represent any 3 consecutive odd integers. This is how you represent it. And the equation is going to make just the ones that work for this show up. I specifically want the ones that make 51. So now I just solve this, like that should be the easy step, 3x. 6, so I subtract 6, right? Equals 45 divided by 3. 15, so this is 15. This is 17. This is 19. If you check it, yay. So on 2 levels here. Okay. If I lost you, can you tell me where I lost you? You're like, actually, you lost me when you came in the door, Jeff. Damn. Damn.
Well, I get it, but the thing that confused me a bit was the odd numbers thing.
True. I'm with you. I'm with you.
Because there's like
The biggest mistake I see is people put a 3 and a 5,
Yeah.
but odd numbers are separated by 2.
Yeah.
1, 3, 5, 7. They're always separated by 2.
Yeah.
So it's like when it asks for a consecutive integer or number is just +1, but because it wants odd, you have to do it the correct
Plus
way.
2. Exactly. Consecutive integers are just 1 apart. Consecutive even or odd are 2 apart.
So basically, counting by 2 would be what you do with odd integers. Pretty much
Yes.
like 2, 4.
And we know that. We just never thought about it directly like that. If I said start counting odd numbers, you go 1, 3, 5, you're adding 2, not even realizing that's really what you're doing. That's what this captures, though. So again, I mean, here's an odd number, right? What's the next one?
37.
35 plus 2, that's right. Right?
Yeah.
37, isn't that the next odd number? Are you with me so far? Is that all right? All right. Some of you guys look like you want to hurt me. 35. The next odd number is 37, which is 2 away from that. What's the next odd number?
39.
It's going to be this plus another 2, right? So there's actually 35 plus 4. Okay, now, does everybody see that? Would you ever do this if all you're trying to do is count by odds? No. But we're trying to do more than that. We're trying to capture the general idea, no matter what. So what if this would have been 47? Would I have actually done anything different?
No.
I would have said 47 plus 2, and then I would have said 47 plus 4, right? And that would have given me that. So what if this is x? What's the next one?
X plus 2.
Yeah. And then what's the next one after that? X plus 4.
X plus 6.
We know that's how they work. Give me any odd number, the next one's going to be 2 away, isn't it? Any odd number. How do I capture? How do I say generally what's the next one? 2 more than that. And then what's the next one after that? 2 more than that. So 4 more than the first one, right? And if I had another one, it would be x plus 6, right? So we are capturing the pattern involved in consecutive odd numbers. That's what this is capturing. And this is something that you know, you just never really thought about it this detailed, I know. But it's actually, at the same time, it's kind of cool. Let me show you something not directly related to the odd number shit. But watch this. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 5 squared is 6 squared is. All right, now watch. I'm not saying this is going to be in a problem. I just want to show you a nifty example of this idea of a pattern. What do I add from 1 to get to 4?
3.
What do I add from 4 to 9?
5.
From 9 to 7? I'm 16, sorry, I gave away an answer. From 16 to 25? Is there a pattern here?
Yeah.
Holy shit! So to get from one odd to the next, from one square number to the next, you add the next odd number. That's weird. Have you guys, has anybody, what's up?
No, I just.
Isn't that neat? Isn't that neat? I don't care if you hate math. Isn't that neat? They're having their own conversation, but I'm taking that personally. Guys, everybody. Teacher talking, students listen. Okay. Isn't that interesting, at least? To some degree, right?
Yeah.
Now watch, stay with me. So this is what I mean by a pattern. This is a more complicated pattern. It's not really crazy complicated, but it's really unexpected, right? But watch this. You guys cool with me calling these square numbers?
Yes.
Of course, because 1 squared, 2 squared, 3 squared. Now watch, here's 1 squared. Here's 2 squared. Right? Is that cool? You can see that? How many more dots are there from here to here?
3.
How do I make 3 squared? I would put 1, 2, 3, 4, 5 dots, plus 5. I would make 4 squared. 1, 2, 3, 4, 5, 6, 7 more dots. Because that's the visual idea behind what I see here. A ton of math is about finding a pattern and then using the pattern. I actually use this trick to figure out squares of bigger numbers. I have memorized some squares, and then I just add odd numbers till I get to the one I want. And I don't do that a lot. I'm not going to go on, I'm a human calculator. I ain't a human calculator. I just know a few things that'll help me with some stuff. Who cares? Right? But this is a neat trick to know. Okay. So, watch this. Is everybody cool with, or has everybody got that? I won't say cool with it. I don't want to make you lie. Okay. So let me try this. Let me try the next kind of level to this. What if I said, let's see, I have 3 consecutive even numbers, right? Let's see. Let me make one that, it'd be nice if it would work, isn't it? Wouldn't it be nice? Let me make it work. The sum of the first 2 is equal to, let's see. You got it, Jeff. 8 more than the last one. Really, Jeff? Really, Jeff? Really? You gonna do this to us? Yes. I want, now this is sounds a little more complicated. Are you with me? My real purpose with this is to show you that the first step doesn't change. I still fundamentally have 3 consecutive, in this case, even numbers. Stay with me now. The math part does not affect the first thing I do. That's why I said the first part of a word problem has nothing to do with math, really, unless it has some kind of like a pattern. The very first step is just, what are the players? So what do I write down for the players in this? What's involved? No math. English.
First.
First number? Yes? 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 Second number? And third number. You can call it first, next, and last. I don't care. Just give them some kind of English names. That is your first step. I really want you to bring that to heart. Your first step in a math word problem does not involve math. Because fundamentally, it is translating from English to math. I got to know what the hell the English is before I can translate it to mathish. Right? Somebody really turn tail quick. All right. So we already know how to set these up. What's the first number? X. What's the next one got to be? X plus 2, right? Because even numbers, 2, 4, 6, they're still separated by 2, aren't they? And so the last one's got to be? Do you see? That is separate from what the hell they do with each other. That step. I don't care what they're doing with each other. I got to set up what the hell they are first. Then I worry about what the hell Jeff just did to us. What the shit is this, Jeff? All right, let me see. Let me see if I can get you. What's this say? The sum of the first 2. So what are the first 2? X and X plus 2. The sum of the first 2, this one and that one, and that was really nice here, right, is equal to 8 more than the last one. Yes, 8 more than the last dude. Right? You're not used to it, but it isn't that insane. Once you get, is everybody cool with this step right here? Let me make sure. Or cooler than you were earlier.
Why would it be the same as the odd number?
You ready? Count odds. 1, count 3, 5, 7. They're separated by 2. Aren't the even ones in between those?
Yeah.
Don't they have to also be separated by 2 then, or else they would overlap? I love it. Now watch, real quick. The real fundamental question that you're asking is, these are supposed to represent even. Why do they look the same as the odds? Because if I start with an even number, these are all even.
Yes.
If I start with an odd number, these are all odd. Do you see that?
Yes.
So of course they look the same because they both have the same pattern. But my answer is going to have to be an even number for this thing to make sense. Otherwise I'm going to go a whole bunch of odd numbers and it said it's freaking even. What the shit? So there's a distinction between the pattern between things and what the shit they are. Right? Shit. I don't know. I keep saying shit. Shit. So the sum of the first 2. Bam. The sum of the first 2. That one and that one. They're the first 2. Is 8 more than the last one. And now that equation kicks a lot of ass. Maybe, right? Now the thing with students, I think, is you start to solve the equation, but you still have this in your head. Who gives a shit where that came from? That's an easy equation. Right? Let go of this crap. It doesn't matter right now. I don't care about us solving that and that. You're like, please give me more of those, Jeff. You should be. Right? What do you get? You get 2x plus 2. X plus 12.
You can take the X on the other side.
Good. Subtract X. Might as well subtract 2. I get X is
X equals negative.
10.
Yeah, 10. Sorry, not negative. Just 10.
Is that even?
Yes.
So what's the first number? 10. What's the next number? 12. 14. Now let's check it. The sum of the first 2, what would it be? 22. 8 more than the last one. What's 14 plus 8?
22.
Holy shit. How did I make that problem? I actually just came up with these 3 in my head, and then I figured out those added is 8 more than that, and I made it into a problem. So I started with the answer, and then I made a problem out of it. Sort of like we did yesterday with that example. Okay, maybe. I understand that word problems seem incomprehensible. They often seem, but I'm trying to show you the parts to focus on one piece at a time. I think students sometimes think I'm supposed to read this once and then have the equation ready to go. That is the definition of insanity. Ain't no way you're going to do that shit. You got to take it. First step, what's going on? Second step, translate to math. Third step, how do they all relate? And then you got an equation to solve. You can't jump to the equation. You're not expected to, and it's going to get you to finish the problem quick. You're going to get the wrong answer real quick. Right? But what good is that?
So that's where like when the algebra steps come in, like you have to actually.
Yeah. All right. Maybe. All right. Let's see. Okay. I want to. All right. I'm going to give you this. Actually, let me do a problem with you. I'll give you this, and then we'll call it a day. How's that sound? All right. Well, I got to figure out something so I can use more board because I can't do too much. Has everybody got that problem up there? Yeah? No? Has everybody caught that one? Oh, go ahead. I'll do over here. No, you don't. Okay. All right, let's see. Let's see. A rectangle. So a rectangle has a length that is 2 more than twice the width. There's not like a ton of stuff going on there yet. All right, maybe I should make one that works. Let's see. Oh, yeah, the perimeter is 22. Find the side lengths. So the length and the width. So, I still have the same fundamental steps, but I can add one that I talked about earlier. I can draw this thing, right? So, draw a little rectangle. Boom! Look at that rectangle, it's so cute. What are the players in this problem?
Length.
The length and width, I love it. The perimeter is going to be where the equation comes from, right? So I'm going to write length, width. How are we doing there? Everybody can see. Right on the edge of it. So there is a step I could do. I can draw it. You don't have to draw it, but it's a really good idea to draw it. You'll see why in a minute. Then I still identify the players in English. Now, can you guys see the idea of who's just X doesn't really change? Can you see who depends on the other thing? What's got to be known first, the length or the width? The length is 2 more than twice the width.
So the width needs to be compressed.
Yes, do you see that? Whoever has shit happening to him to make the other guy, I got to know that guy first. I got to know the width first. Let's be crazy. Let's call the width W. Oh my God. I'm gonna report you, Jeff. What the shit is that? So what's the length gotta be then? Yeah, 2 more than twice the width. So 2W plus 2. Now, here's W. Here's 2W plus 2. Is that cool? So, you guys with me? So use the picture you just drew. And you're gonna see why real quick. What is wrong then Can I come over here? Everybody got this?
Yes.
What is wrong with this equation? What's perimeter mean? You have to go how far around it? All the way around it. And if you do W plus 2W plus 2, you have only gone halfway. To be really honest, I would put 11 there, but screw that. If somebody sees what I mean, then you can do it. But how do I get all the way around the thing? W plus 2W plus 2 plus
W
plus
2W.
exactly. So I need another W and another 2W plus 2. What's perimeter mean? All right, let me stop. Identify where I lose you. Is everybody okay with the picture I drew? It's the rectangle. Is everybody okay with length and width of the players? Is everybody okay with width has got to be a letter?
Yeah.
Yes. Once I call that W, the other one is 2 more than twice, so that length is there. Is everybody okay with how I wrote these on the picture? Because the width is W and the length is 2W plus 2. Is that cool? Is that all right? Oh, man. You guys are like, I ain't going to tell you, Jeff. That's your job, man. You're the teacher. Come here. Does that make sense? Did it make sense? If you only do this, you've only gone halfway. Do you see that? How do I get all the way around this thing? How far do I have to go? I have to go W plus this, 2W plus this plus this. That's exactly what the hell that says. That is the perimeter. And what do I know the perimeter is supposed to be? 22. That's why I set it equal to 22, because that's what it's supposed to be. So the biggest mistake people make on a rectangle problem is they only go halfway. Because they didn't draw the picture. They don't stop. They just focus on the algebra words they see. And they're like, hey, I got W and I got 2 more than twice that. I'm good. But that doesn't make physical sense. Right? If you're a security guard, you are not going to be paid much. You're like, you don't even get to the other side of the freaking lot. I'm going in there. Yeah, yes.
So the reason that you put it twice is because, just to make sure, it doesn't have, you're trying to find the length of one side, but then
No. Listen. The only reason I put them twice is because it told me what the perimeter was. How do you get the perimeter of anything? Yeah. Oh, did it not give this out? Oh, yeah, that's right. I was going to give it. Go ahead.
Okay, thank you.
You add up all the sides. It's that simple. I have to add that to that to that to that. And that's what I've got, right? That's it. That's all. Perimeter means all the way around, so my equation better go all the way around. And then I got 3W, 5W, 6W. Right, subtract 4. I got 6W is 18 divided by 6. I got W is 3. Right? Not a hard equation. You guys could do that. So W is 3. So what's the length? 2 times 3? 6 plus 2 is 8. Yeah.
8 plus 3 is 11.
I know, but that's only halfway, isn't it? 8 plus 3 plus 8 plus 3 is 22. Okay, maybe. Again, how long do we do this section? Have you guys looked at your homework sheet? This is through next Wednesday, right? So we are still getting into the idea of word problems. I still have, let me give you this. We'll get more into this next time. You can look at this now if you want to. This is more generalized word problems. Anytime. Try to look through my examples. By the way, section 3.2, we sort of skipped for now. We're going to come back to it. Section 3.2 is all about percentage problems. Guys, 3.2 is all about percentage problems. So if you want to try it, you can, but we haven't talked about it. Percentage word problems yet. So, yes. I didn't give you one. See again? Yeah, we did. You could do 3-1 and 3-3 for sure. Yeah.
So don't do 3-2.
You can try 3-2, but it's percentage word problems. We haven't really talked about it. W plus 2W is 3W. Plus 2W is 5W. Plus W is 6Ws. I only see 6 W's. 1 plus 2 plus 2 plus 1.
So you didn't count the other two?
I don't see any more W's. That's a 2.
Oh, is that?
That's not like terms with 2
I thought it
W.
was the double.
No, just a 2.
Oh, it's a
Yeah.
two.
Just a 2.
Got it.
Yep. All right. That's it, guys.